Hello and welcome back to Introduction to Number Theory. We continue our study of fractional part of n alpha, where n is an integer and alpha is a real number, actually an irrational number. So n is an integer and alpha is a real but not rational. May I remind you that n alpha, fractional part of n alpha, as well as fractional part of any real number, belongs to a semi-interval from 0 to 1. So we often just draw a circle from 0 to 1 in such a way, with 0 here and 1 in the same place, and simply mark points on this circle that correspond to alpha, 2 alpha, 3 alpha, and so on. And we know from Kroneker's theorem that these marks are dense on the circle, which means that for any interval whatsoever on this circle, there exist infinitely many marks inside this interval. If we imagine a grasshopper that jumps with a step equal to alpha, then he will get to this interval infinitely many times. This is Kroneker's theorem. But what if we try to answer a more difficult question? How often does a grasshopper pop into this interval? What is the frequency of visiting this interval? Can we be sure that if we take two intervals, one with rather small length and the other one with greater length, then the grasshopper will pop into smaller interval less frequently than in the greater one? In order to answer all these questions, first we need to define what is the frequency of popping into an interval, and what do we mean by how often. For this purpose, let's count the number of popping into interval within first n jumps of the grasshopper. This means that we should consider the set of all m such that m is between 1 and n, and the fractional part of m alpha belongs to the interval. So this is the set of all jumps where the grasshopper gets into the interval. And now we count the number of elements of this set, divide it by n, and this is the frequency of popping into the interval within first n steps. We understand that, of course, it depends on n very seriously. And what is interesting is whether there is or there is not a limit of this expression. Actually, it's a function of n. Whether is there a limit of this function of n when n tends to infinity. So this expression here, from the beginning of the limit to the end of the fraction, is what we call the how often the grasshopper pops into the interval. And we see here that it can depend on many things, but it can depend on where this interval is on our circle. It can depend on alpha. It can depend on, well, I believe that only where the interval is and alpha. But it turns out that this frequency of popping into the interval depends only on the length of the interval, and actually it is equal, well, since the length of the entire circle is equal to 1, so this is equal to the length of the interval. This statement is called Weyl's theorem. It is not so easy to prove, but nevertheless, we'll try to do that in several following fragments.